how are we going to get deliveries up there? So like, I want to clear out all the agapanthus and all of it and dig down behind the wall. And it's just another little trick I've learned to keep a project moving. Yo, remember when this was a big gigantic hole? I'm Josh, a builder here in New Zealand, and this is the gnarliest site I've taken on to date. Down on the street is 81 meters above sea level. Where the guys are up there on the build platform is 98 meters above sea level, and that's how you get an epic view, but that's also how you get a gnarly site. So this is actually a multi-generational site, and our clients and their mum have gone in on the land and they're building two houses. The front house at the midway point is going to be for the mum and is 125 square metre, 2-bedroom, 2-bathroom, really nice home for our client there. And then all the way up the top of the section we are building another home, 245 square metres. This one is 4 bedrooms, 2 bathrooms and a study, and large garage downstairs with room at the back for a gym and bike storage, and a large north facing deck out the front of the building capturing all those views. Got a huge driveway. We have to build a big retaining wall down there, a lot of earthworks and a lot of engineering to even get to the building site. We've had some engineering issues on site, and we're going to have to actually carry this retaining wall along the corner here to prop up this corner of the driveway. Driveway has been designed to meet all the required gradients, and it's definitely like a chicken and egg scenario where we wanted to pick a floor level for the house, but then you got to get the driveway to work, and so it's moving those things up and down to make sure that the entire site plan works. So those things are exasperated by steep sites. In this first meeting here on site, we are catching up with the main builder and the digger driver, and we're coming up with a plan. Given that it's a really steep site, we have a retaining wall and a house towering over us here, and then we have a very big drop and we're towering over a house here. I wanted to come up with a really clear health and safety fit plan. During that meeting, the surveyor was also on site. So we'll ask the surveyor to mark out something such as the building line, the edge of the building, or where the garage basement's going to get cut. The surveyor will then bang pegs into the ground, and using her GPS instrument, she'll get it super accurate within a millimeter, and then a little nail goes in the top of that peg. Now with a series of pegs, we can use that to start forming building lines. And then we put in another stake a little bit higher, that gets spray painted. This makes it real clear and obvious to everyone, like digger drivers, where those pegs are. It's super important that we protect them, don't knock them. We want them to be accurate so we can actually use them. Before we can crack into earthworks, we needed to establish silt fences on site. So as you cut open the earth, it rains, it runs across the surface and picks up dirt. And then the idea is that it gets trapped in your silt fences, the silt stays behind, and then you're not clogging up the stormwater systems with silt and dirt and all that yuck stuff from site. Now that this is done, we can jump into the earthworks phase of the build. Just down here is forming the front edge of the driveway, and there's a 2 meter high retaining wall coming in. That has also been marked out for us by the surveyor. So we've benched a platform. Next step here is we're going to drill some big holes, fill them with concrete and nice big retaining posts, build up a wall. We push this dirt along. As well as pushing the dirt along here, we're also pushing our subs up. If you haven't already, go ahead, click subscribe. Help us hit our goal of 100k subs. So we've had a couple of big diggers on site doing a huge cut. We'll show you the basement garage now. Look at this dig out, isn't it a thing of beauty? Huge big walls going in here, 3.6 meters high, nice big deep garage. Right now we're marking out for the footing. You see we've got the string line. These nails are the exact building lines, so we string those lines out and that becomes the edge of our building. We're then marking out for a footing. We'll show you an engineer detail of that plan now. Here we have an engineering plan for the garage foundation. Following this detail here, we're going to cut this section of earth out. That then gets filled with a metal cage. The stirrups go up and into the block wall. That footing is what we can then use to build our block walls on top of, and we will also tie in the concrete slab with this footing. Lots and lots of work to get this out of the ground, but we're taking it one step at a time. We've taken out 600 cubes of dirt and we've got another couple of hundred to go. So they load a survey plan into the computer. Let's say the computer says you're supposed to take out 600 cubes. In experience, as you're digging that out, it fluffs up, it expands. You always end up digging a little bit more, you always do a little bit more. So whenever you're factoring in fill to leave site, times the amount on paper by 1.3, that's usually what actually ends up leaving site. Now we've got a little baby digger over here, big digger for the clear out and getting rid of all the dirt and loading up the trucks. Baby digger for the footings and some of that more fine work. We've also had to do some work up the top there where we will never get a digger again, and we're going to build an access way up the left hand side. It's real crazy, we haven't even put concrete in the ground yet and we're already asking the clients to sign off landscaping plans and working out how we're going to prepare and landscape that area up there, because once we build a house, you're never ever going to be able to get anything up there unless it's by hand in a wheelbarrow. Just something we've learned the hard way on other sites. This is a perfect time to plug my company, Your Place Building Co. We're building a bunch of homes around the Hutt Valley. If you want us to take on a project like this for you, hit us up, we'd love to help out. We have a bunch of these boards around the site. So right here you have garage floor level, and we have lot 1 is future house over there, floor level. You then start to get a bunch of heights. It has been called in the past a story rod. It's a reference point for the site and you keep coming back to it. Always on a sloping site, we set up a bunch of these. So we've also got a height board up there, we've got one down there, and you're always coming back to this. You're always making sure that everything you're doing is double checked against your heights. These heights are in relation to MSL, median sea level. So that laser level over there, we can come over here, we can get this height, we can then shoot that. Again, it's real important to get your heights right in relation to the road, in relation to the driveway. You want to make sure right at the start, while you've got the big heavy earth moving equipment on site, that you get these cuts right. Also part of setting up site is a portaloo, hazard code board, water, power, safety fencing and silt control. So what makes this site the gnarliest site I've taken on? Well, obviously it's the slope. Imagine you've got to get all of your building materials, you've got to get your diggers, you've got to get your concrete, you've got to get your builders and all your steel up this muddy track equivalent to a 4-story building. And you've got a reasonably tight footprint to do that in. On top of all that, we want to do a good job. We want to look after our workers. We want to look after our neighbors. We want to look after the road and the property. All of those things combined mean that we need to slow down. We need to do it one step at a time, and we need to be all over it. Today we just finished pouring 24 holes for these huge 300mm retaining posts. Half of them have had to be drilled into rock. It's literally been 2 steps forward, 1 step back, and it's such a sweet milestone to have these installed, signed off by the engineer, ready for our retaining boards to come in. So on this site plan here, you can see this is where we're building it. So this detail here shows the retaining wall we're building. Using table 4.0, we order all of these SED posts. These show us that they're going in a 600mm hole, how far down they need to go, and how long the post is allowed to be. So if we're retaining 2 meters, we need to have a embedment depth of 2.9. So therefore we need to use a 4.9 meter post. We can use an SED 275 to 300mm post. Look at them, they are literally like telephone poles. 2.2 meters into the ground, they come out 2 meters and retain a bunch of soil, and then they come up another meter and that acts as a car barrier, and we put a balustrade on top of that. Basically it's going to stop any vehicle going over the cliff. This also shows you that the wall is on a 10:1 angle. That's a 6-degree slope. Real important that you have that slope, and this is part of why the wall on the neighbour's property is failing, because whoever built it back in the day did it plumb, and then the force of the earth pushes it over. We're not going to have that problem here. This was my first priority job, but real early on we established the existing wall over there is failing. Basically sometime between 2005 and 2011 the wall got built. It wasn't on the neighbour's 2005 consent, and then it magically appeared on the 2011 consent. So it's been a bit of a show dealing with that and the engineer. Originally this wall we were building was going to have to wrap around and carry on and replace that. We've come up with what's called a Deadman solution, where on this side of the property, 7 meters away from the wall, we drill some huge holes, we fill them with concrete and these posts, and we put a huge big strap back to the wall and we crank it up and we tie it all together. So bit by bit we are resolving our access issues. End of this week here, they're going to cut this, and the gradient of this area will be way more mellow, and it's going to be 5 meters wide. Huge room for activities up here. And then we're going to move into this section here, and we're going to do the Deadman, and then we can finally get our last bit of access up to the slab. That's right, even without access, we have managed to pour a slab up the top. We have a massive 37 meter reach concrete pump. Basement garage is going down. It is a massive achievement to get it down. We've even got blocks to 1.8 meters, half high. Let's go and have a look at that. Look at this, I'm standing on a 70 square meter slab. Remember last time we were here and this was just a big giant cutout? A few of you called me out on the gradient. So we spoke to the engineer and he gave us a better angle, and so we cut that back. We've also covered it in a special cloth that is theoretically stopping it from eroding. So we've put in here 3,000 meters of steel, that's 3 Ks. That would be the length of 32 football fields for you Americans, laid out in steel. This kind of stuff, most of it's like D16, D20, D25. And we have got all of our blocks up here, and we are good to go. So our building yard is just around the corner over there. It's like a 5-minute drive. We decided that with this being a muddy, wet slope, and we didn't have a flat, clean area to work on yet, that for stage 1 of the steelwork, we set up a cutting station in the yard at work. We created a cut list, and now you can use factories to do that for you. In my experience, when you've got a really complicated job, it's easier to do it bit by bit and start to get a feel for how it's all going together. And there's nothing worse than getting a pre-order of steel turn up and you find out that all your runs have been bent 100 mils short, or it's happened to me a couple of times now. We went to start the steel last night and realised that they had sent all the wrong steel. They look a little bit shorter than normal, and so I measured them, and sure enough, the factory docket that they sent out has the right measurement, but they sent them out to the wrong height. And I've learned the hard way to just bend my own steel on an as needed basis, and it's just another little trick I've learned to keep a project moving. It's also a real good way to start getting your head around how all the steel's going to go together on site. You create the cut list, you cut the steel, you place the steel, you pour the concrete, jobs are goldie. I think we've had the engineer up here about 4 times now. We've tested the soil, we've shown him the cutouts, we've shown him the steel, and now he's come back and he's checked the block work, and it has the tick of approval to pour concrete tomorrow morning. Again, bit by bit it's happening, and we are really starting to get a feel for how this site's coming together. Here you can see how much steel we're dealing with. Not only do we have the normal starters for the block wall, but we have all of this junky stuff here in the pilaster, and you'll see in the engineering detail that it goes all the way down, all the way across, and there's a huge footing there that holds this up and stops it tipping over on itself. Here's a detail of the block wall footing we have built. On the plans, different retaining walls are marked as retaining wall C or F, and on retaining wall C and footing A, this cage here needs to be 450 deep. That is actually a huge footing, but imagine that is a big anchor that then serves as holding this wall up and stops it toppling this way. We have starters going up, and then we've got blocks, and as you've seen on site, we are 9 blocks high, so this is what's called half high. So the engineers pass this off, we're going to do a pour. Don't get me wrong, I have lost some sleep on this job, and it's definitely been a complex process to deal with the access and the neighbour and the engineer. And I think that's a really important thing, is like real early on we're like, right, pause, slow down, make sure we talk to everyone, make sure we gather our facts, because I'm the builder following the plans that people way smarter than me have drawn up and designed. What's really cool is our engineer has been really good to work with, and we've brought him up here, we've shown him some of the struggles we've been working with in terms of making his drawings work. He's managed to recalculate some of the stuff and come up with practical solutions. I think that's really important as well. You've got to have someone that is on the same page as you. Here I am on the back side. We're going to go around and we're going to knock off all the high sides. Using a grinder, we'll put an arris on here, and then this all gets painted up, and then it gets primed, and then it gets layered with a waterproof seal. We're using an Ardex product, and then we can start backfilling this area, because above us is where the rest of the house is going to go. We had a couple of little slips in here, and so again, 2 steps forward, 1 step back. You come to work, you've just done all this work putting a footing in, and then you have to spend ages clearing out the fill. We've come up with a few little ideas like this temporary board system to try and separate our work area from the little bits and pieces that are coming down the hill. So one of the footings that way is there, and then one of the footings this way is there, so we actually only really have a tiny little slab in there. I think we ended up using about 7 riprap pods. You can see that on this engineer detail here. And honestly, this thing is engineered for Africa. I just need to hurry up and backfill it so I can sleep at night, knowing that there is a ton of steel in there, knowing that there is an approved layer of fill, and knowing that this hill in this house is not going to go anywhere. When we started our earthworks and started preparing the driveway, we noticed that this wall was going to be an issue. One of the first things we did is stopped work and informed our client and the engineer. The engineer was engaged to complete a report and let us know what our options were. First and foremost, we established that the wall did not meet the requirements of supporting a driveway. Here's a couple of photos from the engineering report. You can see in this one here, the left post has moved the most, both in plane and out of plane. Most of the timber posts are leaning away from the retained soil. That's not good. And here you can see concrete cracking at the base of the timber post. No cracking is present anywhere else. This indicates that the wall has been moving for a while. So this retaining wall was built sometime between 2005 and 2011. It wasn't on the original consent, and then it showed up on the second consent. And even though it's on the edge of the boundary, technically it's owned by the neighbor. It became our client's problem because it's their driveway getting up to their property that this wall was supporting. There was a couple of options, including rebuilding the wall or putting another wall behind this one. In the end, the most cost-effective solution was to implement a Deadman. So what is a Deadman? In engineering and construction, a Deadman refers to a buried or anchored object used to provide support or stabilization. It's commonly used in retaining walls, anchors for structures, or foundation stabilization. Obviously here, we are using it as an anchor 6 meters away to provide support to the existing retaining wall. As well as retaining walls not being supported, you guys are not supporting this channel. Only 20% of you are subscribers. If you're one of the 80% that hasn't subscribed, go ahead, click the button. It really does help us out. We buried these 300mm ECD posts into the ground, and then with RB25 bars, we tied the old wall to the new Deadman, the new structural anchor. To get the bars in a meter below the surface, that means obviously we have to dig out a meter of dirt, and that doesn't sound like a lot. You go 6 meters wide by 10 meters long-ish, and a meter deep, that's another 60 cubes we had to pull out. This is our Deadman solution. These have been concreted in. We've let it set now for a week and a half, and we're going to thread the rods this Friday, but we're not going to crank it up until next week. Obviously all of this has been inspected by an engineer, and we're just following their plans. On this side of the drawing here, you can see the new Deadman, and you can see how far into concrete it needs to go, and that the RB25 is buried a meter below the driveway. So these are RB25s. It's a threaded rod, it's 6 meters long. It's been galv dipped, and look at these giant nuts. This, not my ones. Basically, we put it through, thread it through our Deadman, screw it into the failing retaining wall, crank it all up, and it's never going to move anywhere. You can also see that we're putting it in a 500mm hole, and we are encasing it in 20 MPa concrete. You can see here on the other side the existing retaining wall. We all know it's definitely not on that angle. So I want to clear out all the agapanthus and all of it and dig down behind the wall. We've got the RB25 and we've got the fab retaining wall, drilling a 30mm hole here, one on the Deadman, put the rod through. You can see the RB25 going through the existing wall and existing poles. And then it's got a massive 150 by 150 by 20mm thick washers. Not only did they have to get custom made, they had to get bent to the shape of the pole. We also had to then drill them out after they'd been bent so that we can still get our bar through, tighten them up, pull it all together. It just acts as a huge big structural anchor that prevents that wall falling over anymore. And our client can put their driveway on it and finish off getting to their build. For these guys, we will hopefully be able to crank it up and get it a little straighter than it is right now and give it another 50 to 100 years of life. Once we'd tightened that as much as we could, we now were able to get it inspected by the engineer and backfilled. This is it. This is the wall we had to fix. Every 500 mils we've buried a post here and then it ties into a post over there. A metre below us, the bars go through and then we've had to compact the driveway back over it. We've had a geotech engineer this morning and he signed off all of our work to date, which is awesome. We're working with a great bunch of engineers on this site who understand that what's in your drawings and what happens on site don't always work together. And so it's definitely like a collaboration between us all to make sure that we tick all the boxes. So it's such a good feeling to be standing here now at the top of the drive, knowing that that wall down there is not only strong enough to support a portaloo, but can support the driveway and the trucks and the materials and everything else we want to achieve on site. You know, up until now, everything has been walked from the bottom to the top. It's been painful. Now we can get on to the job of building the house, and there is a huge basement garage underway. So we're using 200 series blocks similar to this. The main ones have another piece in the middle. And we've also got a bunch of these to form the pilasters. Then we put the blocks, we did that in 2 lifts. That gets inspected by the engineer. They make sure that all the steel's there, that it's the appropriate spacing, all of those things. We are 9 blocks high, so this is what's called half high. So the engineers pass this off, we're going to do a pour. This all gets painted up and then it gets primed and then it gets layered with a waterproof seal. We're using an Ardex product. You can see here the blocks have been waterproof and then a protective layer, and it's been passed by the council. That means we can now start backfilling, which is awesome. It means I can sleep at night, not worrying about every time it rains this bank's going to cave away. We've started backfilling on the left side of the building where it's just going to be landscaping. This is the side access to the house. All this room for activities. You could probably even park a car up here. So this is going to carry on up to the backyard. This is also great for us. We're going to use a mini dumper to access the areas where we need to get in fill and compact it. So next steps up here, we're going to do two things. We're going to get the blockies back and do this next lift all the way up, and we're going to start backfilling around these last two sides here. We've got heaps of steel, we've got 7 cubic concrete, and we've got a 3 meter high block wall going here. Finishes the face of the building, and that means we can finally crack on. Yo, so you saw us pouring this pad, and since then we've had a Christmas break, and where are the blockies? I need them back. We need them to put block walls here. We need to finish this block wall so we can backfill and do a slab up there. That's probably one of the frustrating things about the Christmas break, is that the whole industry shuts down. It takes a long time for it to start back up, but we will just keep pushing away and get it sorted. Paul, can you drive up this drive?
I just tried, mate. I got to back up. Usually I used to be able to get up to here.
How are we going to get deliveries up there?
You'll have to spray it or something, mate.
Yeah.
Can't get traction.
One of the many challenges of the site is just getting to the site. As you can see, we are delivering from the road, halfway up the drive. In an ideal world, we would have resolved this driveway stuff way before we started building, but we had the failed retaining wall. We'll get a pump up there. We've already poured a huge amount of concrete up there, so I know we can carry on. But super important to me that we get a working driveway that trucks, delivery trucks, can actually get up. Look at it, 3.8 meters high. We've got a full row of blocks up there, and we have one more row of blocks there. So by end of the day, blocks will be done there. All of that's going to get waterproofed behind. Here's a really good shot where you can see some of the different layers. So here we have raw block, and here we have painted a 2-part primer. Then you can see here we have the membrane, and then we put on it this giant bubble wrap. Basically it is just like bubble wrap. Here's an example here. This goes up against the membrane this way here, and so as we're filling this up with dirt and drainage metal and compacted fill, it's just one more layer of protection between membrane, which is keeping the water out, and all of the earth and all of the water and everything on the other side. This is what drainage metal is. That lets the water easily drain down to the bottom, and then right at the bottom we have a Nova coil that's around the whole thing, so any water that ends up flowing down the hill, getting trapped behind our wall, will go down the drainage metal, out the drain, gone. Bob's your uncle. We're going to reuse as much of that soil there. Engineer has approved us to compact it in 150 mil layers. We're doing everything we can to reuse material on site and save as many dollars as we can for the client. And then we're moving on to the front retaining wall part. This part here is holding up enough earth to build the upper story slab, but also forms the edge of the driveway. What I've learned is if you try and do everything all at once, it becomes super hard. You're more prone to making mistakes, and it's easier to like find a starting point. We knew we had to get a garage slab, so we got the garage slab down, we got it to height. Now we have a flat level surface that's locked in. Then we could start our walls and we could backfill them to halfway. Not only was that a huge motivational boost, but it made the working areas way more usable. Then we cut out this area here. If we'd tried to cut out this area first, it would have held up all of this progress, and we needed a reference point to start everything off. So once this was down and locked in and signed off by the engineer and the surveyor, we could crack on with this part knowing that this is all correct. Rightly or wrongly, you've got to pick a starting point and you've got to work out, do you work your way from the top down, or do you work your way from the bottom up, or do you do a combination? And you've seen on this site, we've been working down there on the retaining wall and the Deadman, we've been working up here on the earthworks and the garage slab, and it's all starting to come together. Yo, remember when this was a big gigantic hole? Now it's not. We're about to deliver a truckload or a couple of truckloads of Basecourse. We're going to fill it all up and then we're going to be ready for a slab. We've got a survey peg there and there. We'll bring a string line across, and before you know it, boom, we're going to have an upper level. We've also got a steel beam coming in here. We've got a mid-floor going over the garage. Man, the view here is amazing. Look at the sun. It is such a perfect secluded spot. I would love to work up here all day, every day. So we got sign off from the engineer to use in situ fill. That means that all the stuff from site we're able to bring back in behind the wall. We have to do that in layers, and then we have to compact it with this bad boy. So first 600 mils or so is drainage chip, and then behind the wall the drainage chip goes all the way down. That means that if any water gets trapped in here, it does not go into the wall, it goes down into the pipes, out and away from the building. But guess what? We're finally preparing an upper level slab. We've even got string lines. We've got profiles, we've got the corners, we've got the plumbers on site. We've got drains in, and we're ready for upper level slab. Then we're going to crack onto the mid floor here, and then we are so close I can taste it. We are this far away from pouring a floor. And once we get our materials up here, we're working on that with the truck and the digger. We will have a normal building site and we'll build a house, and you'll be able to sit on the motorway over there and look at it and be like, wow, that's a cool house. Yeah, and if people come in, why am I painting? It's because I've pitched in to do my bit of hauling materials up the hill, so I can say I was here. Guys, guess what? In 1 hour, we're pouring a slab there, and then that means officially foundations are done on this site. I remember standing here when the clients first rang me. I did a drive-by and I walked up the site, up the old goat track, stood at the top there, and I could actually see it in my head. And that's the thing, I believed that a house could go here, I understood where it was fitting, I was able to wrap my head around that. Does it mean it's been easy? No, man, it's been the hardest thing ever. But I was able to see where a house could go, I could visualize it, I had some input into the design early on. There was a bunch of things we couldn't control, so we've just worked around all of those things. Pouring a slab today, huge monumental achievement on this site. Thanks to the entire team that made it happen. So impressed with all of you. Man, what a crazy milestone. I cannot tell you how relieved I was to pour that foundation, to stand back and see it done. Honestly, crazy journey. If you're still here, you're part of the sign-off squad, and I love that you're watching these videos from start to finish. Obviously, you're loving the progress just as much as I am. How cool that we get to do this, that we get to take a set of plans and put it into action. So my little motivation for you, sign-off squad, is to see this project as it wasn't just one big giant leap. Honestly, it was like a step forward, hit a brick wall, a step backwards, 2 steps forward, hit a brick wall, a step backwards, then build a brick wall, hit that brick wall, and honestly, and it's like, right, I've hit a hurdle, I've hit a brick wall, what am I gonna do about it? Rather than worrying about the entire big picture, worry about the next step. Just do one step after the other after the other. Whether that's you becoming a parent for the first time, starting a business for the first time, changing your career, don't worry about having a 100-point plan, because often what happens is 2 or 3 steps in, you hit a brick wall that you never knew you would hit until you took the first or 6th step. So just take it, whatever you're tackling, whatever you're changing, whatever you're transitioning into, tackle it one step at a time, and put all your effort into doing the next step as best as possible. Enjoy that moment, and then let your journey unfold the way we let this unfold. If you're thinking about taking the next step with your building journey, sign up to the mailing list below, chuck your details in, you'll get extra little tidbits. Surely you've subscribed. Soon we're gonna crack 100K. We're gonna have a little party in the office. Thanks for watching so much. Happy Easter, folks. Yo, you still watching? Have you clicked subscribe yet?